So class, here we will be starting a new subject called Industrial Electronics. Herein we will study different devices which can handle large power. For example, power diodes, power transistors, power MOSFETs, IGBTs, SCRs, all this and their characteristics, switching characteristics, then DC to DC converters, DC to AC converters, SMPS, all this we will study. And the basic of it is devices which can handle large power, that is, we can also call it as a power electronics subject. So to start with, we will study what are power diodes. So before we start with power diode, I will consider the fact that the basic PN junction diode is known to you all and you have all the idea of a basic PN junction diode in order to understand a power diode. In this topic of power diode, we will study this following topics, that is basics of power diodes, why we are using it, types of power diodes, different types of power diodes that are available in the market, then structure of a power diode, the characteristics of a power diode, that is the IV characteristics of a power diode, and the applications of power diode. Now, the basic of power diode is, as mentioned before, in the subject of industrial electronics, we will be studying different devices which can handle large power. Here also, the basic of power diode is to increase the power handling capacity by making few changes in the structure of the diode. Now, power semiconductor diodes are used to perform various applications like freewheeling, energy feedback, rectification that you will study in later units of the syllabus. Now, power diodes are actually PN junction diodes, but which have a higher power handling capacity, and the switching speed of this power diodes is low compared to that of a low power or the general PN junction diode that you have studied previously. So what is the difference of a power diode from a PN junction or a normal low power diode is its switching capacity or switching speed is lower compared to a low power PN junction diode, and it can handle very large power by making few changes in the structure of the diode. Now, the various power diodes that are available in the market is the number one, the general purpose PN junction diode, fast recovery diodes, and the Schottky diodes. All this differentiation is made on the recovery characteristics and the techniques that are used to manufacture these diodes. Number one is the general purpose PN junction power diodes. These power diodes are used for low frequency application like rectification due to their higher reverse recovery time. And also, at low operating frequencies, these diodes are capable of handling currents from very low value to higher values. And the voltage ratings are from 50 volts to 5 kilovolts. Herein, the characteristics of general purpose PN junction power diodes or the main characteristics of general purpose PN junction diodes are being mentioned, which has a capability of handling currents from very low value to higher value at low operating frequencies, and the voltage that it can handle is from 50 volts to 5 kilovolts. Now the second power diode is the fast recovery diode. We will go into the basic structure of a power diode later. Herein we are trying to understand or get some overview of few characteristics of the power diodes that are available in the market. The second power diode is the fast recovery diode. These diodes have low recovery time as compared to general purpose diodes. Therefore, they are turned off more quickly and hence can be used in high frequency applications such as diode connectors and DC to AC converters. These DC to AC converters, DC to DC converters, buck converters, these various types of converters you will study in the later units of your syllabus. Number 3 is the Schottky diode. This is same as a normal PN junction diode, is very similar to normal PN junction diode, but the on-state voltage drop is very low in case of Schottky diode. For example, in case of a regular PN junction silicon, say for example silicon PN junction diode, the on-state voltage drop was almost 0.6 to 0.7 volts, but here it is even lesser, which is almost about 0.3 to 0.4 volts. This is the only difference between a Schottky diode and a general PN junction diode. And as it has lower, the Schottky diode has a low a lower breakdown voltage, that is, or you can say the Schottky diode has a very low on-state voltage drops, for example 0.3 to 0.4 volt. So it has a reverse breakdown voltage or a leakage current also, you can say. When in reverse bias, the Schottky diode has a large reverse leakage current, and therefore if you have a large reverse voltage current, that is the current that we have when the diode is in reverse bias condition, if it is large, that means the breakdown voltage will be smaller, will be lower. If you remember the IV characteristics of a PN junction diode, at the breakdown voltage, the current used to shoot up to a very large value. So if we have a larger reverse current and therefore a low breakdown voltage, that is 1.5 to 100 volts, 50 to 100 volts. Therefore, we can say, from here we can conclude that the Schottky diodes are ideal for high current and low voltage applications. And this is the symbol of power diodes, which is same as a general purpose PN junction diode, which has one anode and one cathode. Herein is the basic structure of a power diode. Power diode consists of 3 layers. The top layer is heavily doped P plus layer. P plus means it is heavily doped, and the middle layer is lightly doped. Lightly doped. N negative layer means lightly doped layer, and the last layer is a heavily doped N plus layer. The heavily doped P plus layer acts as an anode. The thickness of this layer is around 10 micrometer and doping level is 10 to the power 19 per centimeter cube. Here it is written centimeter to the power 3, but it is centimeter to the power minus 3, that is per centimeter cube. The last layer of the heavily doped N plus act as a cathode. The thickness of this layer is around 250 to 300 micrometer and the doping level is 10 to the power 19 centimeter or per centimeter cube. The middle layer of lightly doped N negative is known as a drift layer. The middle layer is the drift layer. The thickness of the drift layer depends on the required breakdown voltage. The breakdown voltage increases with an increase in the width of the drift layer. If we go on increasing the width of the drift layer, the breakdown voltage will similarly get increased because there will be, if you increase this layer, the depletion layer will be increased. If the depletion layer increases, the breakdown voltage will increase. Resistivity of this layer is high because of the low level of doping. Because it is doped lightly, the resistivity of this layer will be increased. If the width of the drift layer increases, then the on-state voltage drop increases. That means, for an IV characteristics of a diode, the slope of the IV characteristics in the forward bias condition is 1 by R. Now, if resistivity is high, then the slope decreases. That is, if the width of the drift layer increases, then the on-state voltage drop increases. Therefore, power loss is more. The doping level of this drift layer is 10 to the power 14 per centimeter cube. The junction is formed between the anode layer, that is the P plus layer, and the drift layer and negative layer. The cross-section area of the diode depends on the magnitude of the current to be handled. Higher the current to be handled, more the area required. That means, from here we can say that if we go on increasing the thickness of the width of the middle layer, that is the drift layer, we can control the voltage that we desire. And if we can control the cross-section area of the drift layer, then we can handle the current that we desire. The current can be increased by increment in the cross-section of the drift layer, and the breakdown voltage, that is the voltage, can be increased with an increase in the width of the drift layer. So the drift layer is the controlling parameter. Now, all that which I have mentioned is been written here. All that I have mentioned about the basic structure of the power diode is mentioned here. One more thing I might have missed is it is a vertical structure. The vertically oriented structure is used in power diodes because the power devices, all the power devices, as it is surface area increases, the forward current increases and it can handle more power. Almost all the power devices have a vertical structure. All that I've mentioned is written over here. Now this is the IV characteristics of a power diode. As mentioned before, it is same as the normal PN junction diode or the conventional PN junction diode. A diode conducts when the anode voltage is higher than the cathode voltage. The forward voltage drop across the diode is very low, around 0.5 volts to 1.2 volt, approximately say 1 volts. In this region, the diode works as a forward characteristic, as you can see in the right hand side. If the cathode voltage is higher than the anode voltage, then the diode works as a blocking mode, that is the left hand side. In this mode, diode works according to the reverse characteristics. Now the IV characteristics of power diode is shown here. the forward current increases linearly with an increase in the forward voltage. A very small amount of leakage current flows in the reverse bias, that is the blocking mode. The leakage current is independent of the applied reverse voltage. The leakage current flows due to the minority charge carriers. When the reverse voltage reaches the reverse breakdown voltage, avalanche breakdown occurs. Once the reverse breakdown occurs, the reverse current increases drastically with small increase in reverse voltage. The reverse current can be controlled by an external circuit, which you will study later. Now, all this is known to you all. As I mentioned, the PN character or the IV characteristics is of a power diode is similar to the normal conventional PN junction diode. There is no difference. So whatever I have said is known to you all. But herein what we see is that the forward voltage drop is at around 1 volts, and we have a large breakdown voltage VB as compared to your conventional PN junction diode. Now the application of power diodes are as follows. That is the rectification, freewheeling, energy feedback, AC to DC converters, DC to DC converter, DC to AC converter, SMPS, which will be taken up in the later stages of your syllabus. So we can end the topic of power diode here. And again, I should mention that you can understand power diodes, and in the later stages the different power transistors, for example power BJTs, power MOSFETs, you have IGBTs. All this you can only understand if you have the basic knowledge of diodes, conventional diodes, BJTs, that is your bipolar junction transistors, MOSFETs. Their conventional transistors, conventional diodes, you have to know their characteristics, and then only we can move forward to power devices. So class, thank you for now.